Hello guys, you're welcome to my channel. Today we are wants to look at what? Atoms and molecules. What is an atom and what is molecule? We all understand that what? The universe itself consists of what? Matter. That is, universe is made up of matter. What is matter? Matter is anything that has what? Mass and can occupy what? Space. And you know that anything that exists will definitely have what? Mass, even if the mass is negligible. And whatever that has what? Mass can occupy space, even if it is very, very small. Now, if what? The universe is made up of matter, then matter is made up of what? Matter is made up of what? Atoms. Now, let's quickly look at some examples to understand the concept of atoms and molecules. But before we go there, if you are yet to subscribe to this channel, kindly do. And if you are watching this video, I urge you to watch to the end, so that we both learn together and we tend to understand everything about atoms and molecules. Now let's see. Let's take for instance that I have bucket of water. This bucket of water, let's take for instance that I have what? A bucket that is like 1 liter. The 1 liter bucket, I can fill it up with some cups of water. Definitely, a bucket of water is made up of what? Some cups of water. So, it means this one is made up of what? Cups of water. Now, if we have what? That the water inside the bucket are some numbers of what? The waters in the cup. That shows that the cup water is what fills what? The bucket water. Now, what made up what? The water in the cup. The water in the cup is quite made up of what? Some drops of water. Now, the drops of water, what was it made up of? It's made up of what? Some tiny particles of water. Now, these tiny particles of water is what we regard as what? Molecules of water. Molecules of water. So, the tiny particles is what we refer to as what? Molecules of water. Now, what's made up what? Molecules of water. What made up molecules of water is what? An atom. And what? An atom is what made up what? Molecule of water. Now, that shows that what? The smallest indivisible part of the water in the bucket is what? Is an atom. Now, the actual meaning of atom is something that cannot be divided further. But is that true? Can't we divide atom further? Yes, we can. Because what? They believe that atom is the smallest indivisible particle, is as what? The earlier belief by scientists. But they later find out that atom itself is made up of what? Some subatomic particles, such as what? Proton, neutron, and electron. This shows that we can break atom to what? Proton, neutron, and what? Electron. Are we together now? So you can see the journey from a bucket of water to cup of water, from cup of water to drop of water, from drop of water to tiny particles of water, which we regard as what? Molecules of water. And from molecules of water, we what? Break it down to what? Atom. And from atom, we can also break atom down to what? Proton, neutron, and what? Electron. That's to tell you that what? Matter itself is made up of what? Molecules. And molecules is made up of what? Atom. An atom is made up of what? Proton, neutron, and what? Electron. Now, as regards the proton is positively charged The electron is negatively charged, and what? The neutron has what? No charge. That is, the neutron is electrically what? Neutral. Now, when we have what? More or one numbers of atom is what made up of what? Molecules. Now, let's consider the atom of an element. Okay? Now, when we talk about the atom of an element, atoms of an element. Now, when we talk about atom of an element, we have what? Hydrogen. We have, let me make it color. We have what? Helium. We have what? Sodium. Okay? Make use of another color for sodium. We have sodium. We have chlorine. We have oxygen. We have nitrogen, and so on like that. Now, here are some of the atoms that we have. We have a lot of numbers of atoms, but let's consider just these few. Now, when you talk about what all these atoms, they are made up of what? Proton, neutron, and electron. And what actually makes them different from each other is the numbers of proton that they have in each other. Are we together now? So the number of proton here is different from the number of proton that we have here. And the number of proton we have here is different from the number of proton that we have here. The number of proton we have here is different from the number of proton we have here. And it's also different from the number of proton that we have here. Okay? So if that should be the case, we can then look at what? We can then look at what? Molecules of an element. When you talk about what? Molecules of an element. Now, how do we go about that? Molecules of an element simply means what? The element that comes together to form what? To form molecules. Remember, an element is an atom. This one 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 is also what? An atom. And likewise the remaining two. They are an atom. Now, and we said what? An atom is what made up what? Molecule. So when you consider what? Molecules of an element. Molecules of an element. When you talk about molecules of an element, we have what? Molecules of hydrogen. The molecules of hydrogen, molecules of hydrogen. What is the molecules of hydrogen? You know that one hydrogen cannot stand alone. Because what? One hydrogen cannot stand alone because it has just what? One electron. And what? Before an element can be stable, it has to what? Attain the duplex structure or the octet what? Structure. That is, these elements must have what? At least 2 electrons or 8 electrons. But this particular element, hydrogen, is having what? Is having 1 electron. Thus, it's not stable. In order for this hydrogen to be stable, it needs what? Another hydrogen. Are we together now? And this is called what? H2. So this H2 is what we call what? The molecules of hydrogen that we can regard as what? Hydrogen gas. Are we together now? So molecules of hydrogen consist of what? 2 atoms of what? Hydrogen. Are we together now? 2 atoms of what? Hydrogen. Okay? If I have what? Helium. For helium, what is going to be the molecules of helium? Now, helium is among what? The noble gas. Because what? It has its duplex what? Structure. Are we together now? So, the molecules of helium is made up of just what? 1 atom of helium. Are we together now? And that's why we might not regard this as molecule. We can just call it what? An atom, because what? It's made up of just itself. So like unlike hydrogen, that is what? Before an hydrogen can make a molecule, it has to be what? Two. Are we together now? So the same thing goes to what? Oxygen. Oxygen molecule. The molecule of oxygen. Oxygen molecule, just like we have what? Hydrogen molecule to be what? To be two atoms of hydrogen. The same thing goes to what? Oxygen molecule is also made up of what? Two atoms of what? Of oxygen. And this is what? O2, which we call what? Oxygen gas. Are we together now? So when you talk about what? Molecule made up of what? One or more numbers of what? Atom. So if you are talking about molecules of an atom or molecules of an element, it shows that what? That particular what? Molecule will consist only that particular atom. Are we together now? You know, when you talk about what? When we talk about hydrogen, we only have two hydrogen. We don't have what? New elements. When we talk about what? Helium, we only have what? Helium. We don't talk about what? New elements. When we talk about what? Oxygen, we only have what? Oxygen. We don't talk about what? New elements. Are we together now? This shows that what? We are talking about molecules of an atom, or we call it what? Molecule of an element. But if I have what? An atom of different what? Of different elements. An atom of different element is going to give us what? Molecule of a compound, which I will be looking at later. Now, as we highlight this, we understand that this is what? Molecule of an what? Element, which we can also call what? Molecule of an atom. What about sodium? We have sodium here. What is going to be the molecule of sodium? Molecule of sodium. The molecule of sodium is also going to be what? Just what? Na. Because sodium is what? Is a metal. Are we together now? So sodium is what? Is a metal. So the molecule of sodium only consists what? One atom of sodium. Now what about chlorine? If I talk about what? Molecules of chlorine. Molecules of chlorine. The molecules of chlorine. So molecules of chlorine. Chlorine also, it has to be what? It has to be two atoms of chlorine for molecules of what? Chlorine. So we have what? Cl2, which we refer to as what? Chlorine gas. Are we together now? So chlorine also, its molecules consist of what? Two atoms of chlorine. In a nutshell, we have to understand that when they talk about what? Molecules of what? Of an atom, it will only contain what? It will contain what? Just one element. When it contains one element, we can call it what? Molecules of an atom or molecule of an element. So if you look at it again, you will see that we don't have what? Another element in it aside from just what? Each individual what? Element. Hydrogen. We only have hydrogen there. Two hydrogen is what made up what? Hydrogen gas. So we only have hydrogen only. We don't have new elements. So two atoms of hydrogen will make up what? The molecule of hydrogen. One atom of helium will make up what? Molecule of helium. Two atoms of oxygen will make what? Molecules of oxygen. And one atom of sodium will make what? Molecule of sodium. Likewise, two atoms of chlorine will make up what? Molecules of chlorine. Now, how do we know about this? For us to know the numbers of atoms that is going to what? Make up what? Molecule of a certain element, we need to understand the atomicity of that particular what? Element. Are we together now? We need to understand what? The atomicity of what? Of the element. Now, what is an atomicity? Let's look into that now. when you talk about atomicity of an element, the atomicity of an element is the number of atoms present in a molecule. So when you talk about atomicity is the number of atoms present in what? In a molecule. So if I talk about molecule of hydrogen, like I said earlier, we have what? 2 atoms of what? Of hydrogen. That means that what? Hydrogen is what? The atomicity of hydrogen is what? Is 2. When I talk about what? Sodium, the numbers of what? Atom present in the molecule of what? Sodium is just 1. That shows that what? The atomicity of sodium molecule is just what? Is just 1. When you talk about oxygen, the number of atom of oxygen that is present in what? In molecules of oxygen is what? Is 2. Are we together now? So that shows that the atomicity of what? Oxygen is also what? 2. Remember, the atomicity of oxygen can also be what? 3 when we are talking about what? Ozone. Because ozone is what? O3. Are we together now? But oxygen gas is what? O2. So the atomicity of oxygen gas is what? Is 2, while that of ozone is what? 3. So in a nutshell, we've understand what we call atomicity. Atomicity is the number of what? Number of atom of a certain element that is present in its what? Molecule. Are we together now? So let's consider what? The following table. So we have this table that shows what? Monoatomic. We have what? Diatomic. And we have what? Triatomic. And we have tetraatomic. And we have what? Octaatomic. Now, when you talk about monoatomic means what? 1 atomicity. And when you talk about diatomic, that is what? 2 atomicity. When you talk about triatomic, that is 3 atomicity. Tetraatomic, that's 4 atomicity. And what? Octaatomic, that's what? 8 atomicity. Now, when you talk about monoatomic, we are talking about what? Those atoms whose one atom made up what? Their molecule. Are we together now? That is helium, for example. Helium is monoatomic. Neon is also monoatomic. Argon is also what? Monoatomic. Krypton is also what? Monoatomic. Xenon is monoatomic. And all metals are what? Monoatomic. Are we together now? Noble gas are also what? Monoatomic. Are we together now? Now for diatomic, we have what? Oxygen, O2, hydrogen, H2, nitrogen, N2, fluorine, F2, we have chlorine, Cl2, we have bromine, Br2, then we have what? Iodine, I2. Are we together now? All these are example of what? Diatomic. Why these are example of monoatomic? What's now the example of triatomic? We have ozone. ozone is example of triatomic. Then tetraatomic, we have phosphorus. Phosphorus. And that is what? P4. Then we have sulfur as what? Octaatomic. S8. Octaatomic. Do we understand this now? So when you talk about what? Atomicity of an element, then we are talking about what? The number of what? The number of atoms present in what? In a molecule. So for monoatomic, we have just what? One atom present in their molecule. So when I ask you what's the molecule of helium, is what? He. What's molecule of neon? Ne. Molecule of argon? Ar. Molecule of krypton? Kr. Molecule of what? Are we together now? So all these, they have what? Monoatomic. Are we together now? Then for diatomic, it means you are having two atoms of that particular what? Element in its molecule. Molecule of oxygen is what? Is O2. So the atomicity is what? The atomicity is going to be what? 2. That's why we class it as what? Diatomic. Molecule of hydrogen is what? Is H2. It means it consists what? 2 atoms of hydrogen, and that's why it is also what? Diatomic. The same thing goes to nitrogen, the same thing goes to fluorine, the same thing goes to chlorine, and others in this particular what? Group. Now, for triatomic, we have what? Ozone. For what? Tetraatomic, we have phosphorus, and octaatomic, we have what? Sulfur, and so on like that. Do we understand this now? Good. If we understand this now, there's another mistake that we always make by convincing what? The atomicity for, what's it called? We will convince atomicity for valency. Now, when we're talking about what? Valency is quite different from what? Atomicity. We make use of what? Atomicity when we're talking about what? Molecule of what? Of an atom. Or when we're talking about molecule of an element, we talk about what? We use their atomicity to write their what? To write their molecular formula. When you're writing down the molecular formula of an element, are we together now? We make use of what? Atomicity. But when you're talking about what? The molecular formula of a compound, or when you're writing down what? When you're writing down a compound, we cannot make use of what? The atomicity then. Why? Because we are talking about what? The mixture of different what? Atoms. Are we together now? Therefore, we make use of what? Valency. Now, what is valency? Let's quickly look into that. You can take down this table. It will be very, very useful as we move on. So, let's talk about valency now. Valency. Now, when you talk about valency, what is valency? Valency is the combining power of an element, with other elements. Are we together now? When you talk about valency, remember I told you that we talk about atomicity for what? For an element only. Just a unique element. One atom in a certain element. But when you talk about what? Valency. Valency is the what? The combined power of an element with other elements. With other elements is the key word there. So when you want to combine what? A certain element with another what? Element. You are going to make use of what? Valency. Not what? Atomicity. Are we together now? So combining one element with another element is what we call what? Compound. Compound. So that's why a compound is not what? A pure substance. Are we together now? So when you're talking about molecule of an element, they are pure substance. Like if I have what? H2, this is a pure substance. Is a pure substance because it's made up of what? Only the atom of what? Hydrogen. O2 is also a pure substance. He is also what? A pure substance. Are we together now? So when you talk about what? Element, their molecule is always what? Is always a pure substance. But when you talk about what? A compound is not a pure substance. Why? Because it's made up of what? Different elements. It consists of what? Different what? Different atoms of an element. Now, let's see, for instance, if I have what? Hydrogen. I have what? Chlorine. Okay, let me make a different color like we did earlier. Okay, hydrogen, chlorine. I have what? Oxygen. I have oxygen, nitrogen. If I have what? Nitrogen. Okay, let's make it like that. Now, if I may ask you now, how many what? How many atoms of chlorine will what? Combine with what? Hydrogen. For you to know the numbers of what? Number of chlorine that will combine with hydrogen, there's need for you to know what? The valency of what? Chlorine. Are we together now? And the valency of what? Hydrogen. Are we together now? So, if we look at that, we see that what? The valency of chlorine is what? Is -1. Abi? And that of hydrogen is what? +1. Therefore, one atom of what? Of hydrogen would combine with what? One atom of what? Chlorine. So, that shows that what? We have H combining with what? Cl. This will give us what? HCl. Are we together now? So, when you combine what? One atom of hydrogen with one atom of what? Chlorine, this will give us what? One molecule of what? HCl. One molecule of HCl. Are we together now? When you combine what? One atom of hydrogen with one atom of chlorine, you will have what? One molecule of what? HCl. HCl is hydrochloric acid. Are we together now? So, one molecule of hydrochloric acid is made up of what? One atom of hydrogen and one atom of what? Chlorine. Do we understand this now? Okay? Now, let's see how many what? How many molecules of what? Hydrogen would combine with what? With oxygen. So, we have what? 2 molecules of hydrogen to combine with what? 1 molecule of oxygen. Are we together now? So, 2 molecules of hydrogen will combine with what? 1 molecule of oxygen to give us what? H2O. Are we together now? So, this H2O is what? Is a compound. We know it to be what? Water. So, 1 molecule of water, H2O molecule. So, 1 molecule of water consists of what? 2 atoms of hydrogen and what? 1 atom of oxygen. Are we together now? Okay. Now, let's see how many what? How many atom of hydrogen would combine with what? Will combine with nitrogen. Okay, good. You can pause the video and give us that. Okay, we need what? We need 3 atoms of hydrogen to combine with what? 1 atom of what? Nitrogen. So we have what? H. Abi? So this will give us what? NH3. So this is what? 1 molecule of ammonia. Are we together now? So that means that in 1 molecule of ammonia we have what? We have 1 molecule of nitrogen and 1 atom of nitrogen and 3 atoms of what? Of hydrogen. So I believe we understand this now. So you can see that this is quite different from what? From that of an element. So we are making use of what? Their valency to know how they can react with what? Another substance. Do we really understand this now? Okay, now let's move on to molecules of what? Let's proceed and look into molecules of compounds appropriately now. Okay, so if I have what? H2O. If I have what? H2O. This is what? This is 1 molecule of water. So in one molecule of water, we have what? 2 atoms of hydrogen and 1 atom of what? Oxygen. And what? In hydrochloric acid, HCl, that is 1 molecule of HCl, we have what? 1 atom of hydrogen and 1 atom of what? Chlorine. And Na2O, we have what? This to be the sodium oxide. So in 1 molecule of what? Sodium oxide, I have what? 2 atoms of what? Sodium and 1 atom of what? Oxygen. Are we together now? So let's put a stop there. Okay, let's consider NaCl, sodium chloride. So in 1 molecule of sodium chloride, in 1 molecule of sodium chloride, we have what? 1 atom of what? Sodium and 1 atom of what? Chlorine. Are we together now? Good. Now let us consider something. And what is that thing that we want to consider? Is what? The interaction between the what? Between the, what's it called? The elements of a thing. Remember that noble gas do not react with other elements like we have it like this. Are we together now? So we have what? The reaction between what? Metals and non-metal. Now hydrogen is non-metal. Oxygen is also what? Non-metal. So when you have what? 2 non-metal, are we together now? In a compound like this, H2O is a compound. When they consist of what? 2 non-metal, the kind of bond they form is what we call what? Covalent bond. You can call this covalent bond, or you call it what? Molecular bond. Molecular bond. How then now? So the kind of bond between what? In this particular compound, the bond in this particular compound, H2O, because hydrogen is what? Non-metal. Oxygen is also what? Non-metal. We have this together. So H2O, again, hydrogen is non-metal, oxygen is also what? Non-metal. The bond that exists between what? 2 non-metal is what we call covalent bond, or you call it what? Molecular bond. Now, when you say covalent bond, in covalent bond there is what? Share of electron. That is, these 2 substances, they share electron. I will buttress more on this when I'm talking about what? Structure of an atom. I will together now. So we'll make a video on that as we move on. Now, HCl, this is also what? 2 non-metal. So we are still going to have what? A covalent bond as well. Covalent bond. So for what's it called? NaCl. NaCl also, if you look at this, this is what? This is a metal. And what? This is what? Non-metal. When you have what? A metal and non-metal, the bond that exists between what? A metal and non-metal is what we call ionic bond. So when you talk about ionic bond exists between what? Non-metal and what? And metal. And what ionic bond simply means is what? It means the transfer of what? Electron. That is, the electron in the outermost shell of sodium is what? Is just 1. And what? The electron in the outermost shell of chlorine is what? Is 7. So this one needs what? 1 electron to be balanced. And this one needs to do what? Lose 1 electron to what? To gain its own stability. So whenever what? The electron in what? In sodium transfer to the electron in what? In chlorine. They too become what? Stable. Are we together now? Therefore, this one will become positively charged because it's the one giving out electron. And this one is receiving just 1 electron. It becomes what? Negatively what? Negatively charged. Are we together now? So the one receiving will become negative, the one giving will become what? Positive. And that is why we have what? The anion and the what? Cation. So the anion is the positive charge, and the cation is a positive charge, and the anion is the what? Negative charge. Are we together now? Anion is negative charge and cation is what? Positive what? Positive charge. So like aluminium, if I have aluminium is what? 3 plus. Are we together now? Chlorine is 1 minus, or just what? Minus. Hydroxide is what? Is 1 minus, and so on like that. Are we together now? So all these are called radical. So you just have to what? Memorize your radicals. That is, there's a way you can download what? What's it called? The chart of what? Valency. Are we together now? So that you know the word, the valency electron of what? Each element. Do we understand that now? Now let's see how we can write down what? Some molecular formula for some certain what? Elements. Do I just say element? Sorry, I mean compound. Okay, now let's see how to write down what? The molecular formula of the following substance. So write down the molecular formula of the following substances. So we have to write down the molecular formula of the following substances. Let's see how we can do that. So here we have what? We have nitrogen. So if the question says you should write down the molecular formula of nitrogen, the first thing you need to ask yourself is that what is the symbol of what? Of nitrogen? It is what? N. Now because what? This is just what? A single atom. That is a single what? Element. It's not what? It's not combining with another element. You know you have to make use of what? The atomicity, not the valency this time around. So for you to write down the molecular formula of what? Nitrogen, you have to know the atomicity of nitrogen. And if I may ask, what is the atomicity of nitrogen? Correct. That is what? 2. Therefore, nitrogen, the molecular formula for nitrogen is going to be what? N2. Now, if I want to write down the molecular formula for neon, before I go into that, I have to know what? The symbol of neon. So the symbol for neon is what? Ne. Now, what is the atomicity of what? Of neon? Because here again, we are just dealing with what? One substance. This is just what? One element. Are we together now? And once it is just one element, you consider the atomicity to write down the molecular what? Formula. So the atomicity of what? Of neon is what? 1, because it is a noble gas. Okay? So if that should be the case now, we just write down what? Ne as the molecular formula for neon. That's why it is considered as an atom instead of what? Molecule. We can also consider it to be what? A molecule. There's no qualms in that. Do we understand that now? Okay, so let's move to the next one. And what's the next one? Okay, I have what? Ferrous chloride. Ferrous chloride. So when you talk about this ferrous chloride, I would like you to understand something. Ferrous or ferric. When you talk about ferrous, or you talk about what? Ferric, you are talking about what? Iron. Now, it simply means what? The higher one, and what? Us simply means what? The lower one. That shows that there are some elements that always have what? 2 valency. Like what? Iron. Iron have what? Valency electron 2 plus, and it also have what? Valency electron 3 plus. Okay, sorry. Okay. It has what? 3 plus, and it has what? 2 plus. So whenever they talk about us is talking about the smallest one, because there are some other elements also that also have what? 2 type of what? Valency electron. And there are some that even have what? 3. Don't worry, when we talk about valency, we'll talk much about that. But you can download what? You can download the chart of what? Valency for all elements. Are we together? So let's move on now. Ferrous means what? The smallest one, which is what? 2 plus. And ferric means what? The highest one, which is what? 3 plus. So when you say ferrous chloride, you know, this is between what? Iron and what? Chlorine. Are we together now? Iron and chlorine. So since we know that it's between what? Two elements now, we are not going to consider what? Atomicity, but we are going to consider what? The valency. Now, are we to use the what? The high valency of iron here or the low valency of iron? We use what? The low, because it is what? Us. Are we together now? So we have what? Iron, which is what? 2. And we have what? Chlorine, which is what? 1. The valency electron of chlorine is 1, and that of what? Iron is what? 2. So we cross multiply. When you cross multiply, these two is said to go for what? Chlorine, and this one is said to come for what? Iron. So we have that the ferrous chloride is given as what? FeCl2. You have to write down the metal first before the non-metal. Do we understand that now? So that shows that in one molecule of what? Ferrous chloride, we have what? 1 atom of what? Iron, and we have 2 atoms of what? Chlorine. Do we understand that now? Okay? Since I've explained the difference between what? Ferric and what? Ferrous. Okay, I would like you to write down the molecular formula for ferric chloride. Ferric chloride. Ferric chloride. Ferric chloride. Okay? Pause the video and give us what? The molecular formula for ferric chloride. Okay? Thank you. So, since it is what? Ic, we make use of what? The 3. Instead of what? The 2. If it is us, we make use of what? 2. Then chlorine is what? Is having 1 valency electron. So when we cross multiply, we have what? FeCl3. So that means that in one molecule of what? Ferric chloride, in one molecule of what? Ferric chloride, we have what? 1 atom of what? Iron, and 3 what? Atom of chlorine. Let's look at more example. Okay, I think I have another one here. Cupric oxide. Okay, when you talk about cupric oxide, you already know that this is what? This is going to be a compound, because it's between what? 2 different atoms. That is copper and what? Oxygen. Now, copper, like what? Just like we have 2 valency for, just like we have 2 valency for what? Iron. We also have 2 valency for what? For copper. We have what? 1, and we have what? 2. So that is, we have copper that the valency electron is +1, and we have copper that the valency of electron is what? +2. Now, how are we going to know the one to use out of these 2? Remember, I told you that once you have what? Ic, that is the highest. But when you have what? Us, that is what? The lowest. Therefore, cupric oxide is going to be what? Is going to be Cu, then we have 2 here, then we have what? Oxygen, O. Are we together now? Which is also what? 2. The valency electron of what? Oxygen is what? 2. When you cross multiply, we are going to have what? Cu2O2. Now, because what? 2 can cancel 2, or because 2 is common, we can just what? Eliminate it. Therefore, we have that cupric oxide is said to be what? CuO. Now, there's something that examiner might be crazy about to test you as a student. If they ask you to write what? The formula for copper oxide. Copper oxide. Mind you, copper oxide is the same thing as what? Cupric oxide. Sorry, cupric oxide here. Copper oxide is the same thing as what? Cupric what? Oxide. Do you understand that? That is, it is also what? CuO. Do you understand this now? Okay, let's look at more. Okay, let's look at aluminium hydroxide. Okay, I think I like this. Aluminium hydroxide. Aluminium hydroxide. So when you talk about aluminium hydroxide, okay, when you talk about aluminium hydroxide, you should know that we are talking about what? 2 elements here. That is, this is going to be what? A compound. We are making use of what? Valency. Now, This aluminium, we have this to be what? To be 3 plus. Abi? The valency electron is what? 3. Hydroxide is what? OH what? OH 1 minus or OH what? Minus. That is what? Hydroxide. So if this one is 1 and this one is 3, if I cross multiply, I'm going to have what? AlOH3. Am I right with the way I wrote it like this? No, I'm wrong. Why? Because hydrogen is not standing alone. Hydrogen and oxygen, they are together. Putting these 3 here, it means that it's meant for what? Only hydrogen. Thus, this is what? Wrong. So for aluminium hydroxide, I will have it to be what? AlOH in brackets, then what? 3. Do we understand that now? So that will give us what? Aluminium hydroxide. Okay? But what about ammonium hydroxide? Okay, ammonium hydroxide. Okay, I will leave that to you. Ammonium hydroxide. Okay, so you can try this on your own. You can write it down. Let me know what the answer will be in the comment section below. Okay, so let's move on to some other ones like calcium carbonate. Okay, calcium carbonate. Calcium carbonate. How do we write down the molecular formula for calcium carbonate? Okay, calcium carbonate. So when you talk about what? Calcium carbonate. Carbonate means what? CO3. How then now? Carbonate means what? CO3. That is carbonate. And what? Bicarbonate. We have carbonate and we have what? Bicarbonate. CHO3. That is what? Bicarbonate. Are we there? Now, the valency electron for carbonate is what? 2. Are we together now? Valency electron for carbonate is what? 2. While the valency electron for bicarbonate is what? Is 1. Do we understand this now? Good. How can we then write down for what? Calcium carbonate. So we know it is between what? Calcium and what? And bicarbonate. CO3. So the valency electron of this one is 2 and the valency electron of this one is also what? 2. By the time you cross multiply, we are going to have what? Ca2CO6. 2 times 3 is what? 6. Now because 2 is common, if 2 should divide this one, it becomes what? 3. Therefore we have that calcium carbonate is what? CaCO3. Do we understand this now? Okay, so what will be for what? Calcium bicarbonate. Calcium bicarbonate. Okay, bicarbonate means what? HCO3. So calcium is Ca, which is what? 2. Abi, and what? Bicarbonate is what? CH3 and what? CHO3 rather. And we have the valence electron to be what? 1. If I cross multiply, I will have CaHCO6. Are we together now? Okay. Am I right with the way I wrote it like this? No. Am I right? Yes, I do. So this is going to be what? CaHO63. Wrong. It's not correct. Why? Because what? This 2 is meant for everything here. It's not meant for what? Oxygen alone. Therefore, I'll write it as what? CaHCO3, then into bracket what? 2. So this is the correct formula for calcium bicarbonate. Do we understand this now? Okay, so we have some other examples here like sulfur dioxide. So sulfur dioxide, if I say sulfur dioxide, that is so cheap. You don't even need to know the valency. You know, di simply means what? 2. So when I say di, it means what? 2. Sulfur dioxide, sulfur dioxide. So this what is just what? SO2. And sulfur trioxide, that's going to be what? SO3, and so on like that. So before we go on, I would like us to quickly recap and show something about what we have learned so far. When you talk about what particle, particle is divided into what? Into three. We have what? Molecule. We have what? Atom. And we have what? Ion. Are we together now? Molecule, atom, and what? Ion. You know, atom is what divided into what? Proton, electron, and what? Neutron. Now, in an atom, if I have just what? If I have an atom like this, an atom is made up of what? Nucleus. Out there now, the center mass of an atom is what we refer to as what? The nucleus. Where we have the neutron and what? The proton. Are we together now? So the neutron and the proton, they are inside what? They are inside the nucleus. And outside the nucleus, that is, outside the nucleus, we have what? Electron. That is the position of these three elements in what? In an atom. Do we understand that now? Now, in an element, we have what? The same number of what? Electron and what? Proton. That is why an element is always electrically what? Neutral. Because the number of proton is equivalent to the number of what? Electron. Are we together now? But when you talk about what? Ion, we don't have what? We don't have an ion to the what? Neutral. Why? Because there is always deficiency of what? Electron or deficiency of what? Proton. Are we together now? We talk more about that when we are talking about what? Structure of an atom. I believe this is a good place to stop. If you are yet to subscribe to this channel, kindly do and drop a positive comment. Have a nice day.